Welcome to the Sleepy Facts channel and thank you for finding your way here tonight. Perhaps your mind is still racing from the day, or perhaps you're simply searching for a quiet place to rest your eyes. Tonight we are going to leave the shore far behind. We are going to descend, step by step, into the deep blue. There is nothing you need to do right now. No problems to solve, no emails to answer. Just allow your body to feel heavy and your breath to slow. Let the noise of the world above fade away, replaced by the rhythmic, eternal pulse of the sea. Because tonight we aren't just looking at the water. We are entering the largest living space on our planet. A world of ancient silence, crushing pressure, and bioluminescent light that has existed for millions of years. But beneath the waves lies secrets. Strange currents that circle the globe, invisible mountains taller than Everest, and creatures that have remained unchanged since the time of the dinosaurs. We will drift gently from the sun-drenched surface down through the blue shadows, past the twilight zone, and into the absolute darkness of the abyss. You'll hear of underwater waterfalls, immortal jellyfish, and the quiet, unfinished story of a world that is still largely unknown to us. Some of what you hear tonight may surprise you, or at the very least, spark a gentle curiosity as you drift off. And if these calm, quiet explorations help you unwind or give you a peaceful way to end your day, consider liking and subscribing to the channel. It helps others find their way to this peaceful corner of the internet. Now, let's take a deep breath and begin. The ocean is the true heart of our planet. We often call Earth the blue planet, for a reason. The ocean covers more than 70% of the Earth's surface and holds 97% of all our water. It is a place so vast that if you were to fly a plane over it at top speed, it would take you more than a week to cross the Pacific Ocean alone. Yet, despite its size, we have explored less than 20% of it. It is a place of eternal night, freezing cold, and intense pressure. But even in these hostile conditions, life persists in ways we are only just beginning to understand. It is a testament to the adaptability of nature, a quiet reminder that wherever there is a niche, existence finds a way to bloom. The ocean is surprisingly loud if you know how to listen. We often imagine the deep sea as a library of silence, a place where sound goes to die. But if you were to listen with the right ears, the ocean is actually a noisy place. It is filled with the cracking of snapping shrimp, the low-frequency songs of blue whales traveling thousands of miles, and the rumble of underwater earthquakes. Sound travels 4 times faster in water than in air, moving with a gentle, liquid efficiency that connects every corner of the sea. It is a hidden symphony, playing constantly beneath the waves, a hum of life that has been going on long before humans arrived to hear it. Light disappears quickly as you descend. The ocean is not a uniform blue world, it is a layered one. As you begin to sink away from the surface, the sunlight begins to change. Water absorbs different wavelengths of light at different rates. Red is the first to go, vanishing within just a few meters of the surface. This is why many deep-sea creatures appear red to our eyes. At depth, red looks black, making them nearly invisible. Next, orange and yellow fade away. Eventually, only blue and green light remain, painting the deep in a twilight gloom that is beautiful, eerie, and profoundly quiet. The epipelagic zone is the sunlight zone. This is the thin layer at the very top of the ocean, usually extending down about 200 meters. It is here that the vast majority of the ocean's visible life lives, because it is here that the sun's energy can still penetrate. This narrow band produces about half of the oxygen we breathe on Earth, generated by microscopic drifting plants called phytoplankton. Every second breath you take was gifted to you by the ocean. It is a bustling, energetic place, teeming with fish, turtles, and whales, all living in the sun-drenched shallows of a world that grows darker with every meter you drop. Phytoplankton are the invisible forests of the sea. Drifting in the sunlit zone are billions upon billions of microscopic organisms called phytoplankton. They are so small that millions of them can fit in a single drop of water, yet collectively, they generate most of the planet's oxygen. They form the base of almost every marine food chain. They are the grass of the sea, tiny floating plants that turn sunlight into life-sustaining energy. Without them, the ocean would be an empty desert, and the air we carry would be too poor for us to breathe. They are the unseen foundation of our world. The ocean has a skin. Most of us look at the ocean and see a water, but on the very top, there is a thin, fragile layer known as the nustin. It is only a fraction of an inch thick, but home to unique creatures that spend their entire lives floating on the interface between water and air. Here you can find small jellyfish called by-the-wind sailors, blue buttons, noddles, and even a snail that builds a raft of bubbles to float upon the surface. It is a world of wind and wave, an unstable place to live, but one full of color and brilliance just above the depths. The ocean is getting more acidic. The ocean absorbs about a quarter of the carbon dioxide that we release into the atmosphere. While this helps to slow global warming on land, it has a profound effect on the water. It makes the ocean more acidic. This chemical change makes it harder for creatures like coral and shellfish to build their skeletons and shells out of calcium carbonate. It is a silent crisis happening out of sight, a change in the very chemistry of the sea that threatens the foundations of the food web. But life is resilient, and some marine creatures are already adapting to the new conditions, finding ways to build shells in a more acidic world. The ocean has an invisible current called the global conveyor belt. The ocean is in constant motion, driven by wind, temperature, and density. The densest water in the ocean is cold and very salty. It sinks deep down near the poles and begins a slow journey along the floor of the sea, eventually rising back up in other parts of the world. It is called the global conveyor belt, and it moves water all over the globe. It takes 1,000 years for a water molecule to complete one loop of this circuit. It is the slow heartbeat of the planet, regulating temperature and distributing heat from the equator to the poles. Without it, Earth would be a much colder, more extreme place to live. Salt water is different from fresh water, not just because it is salty. Because of the salt content, seawater freezes differently. It freezes at a much lower temperature, about -1.9 degrees Celsius. And when it freezes, it doesn't form a solid block of ice. It forms thin layers of crystals called fragile ice that float to the surface. As these ice crystals clump together, they trap brine between them, creating a salty seawater that is denser than the surrounding water. This salty water then sinks, creating brine channels that pump nutrients from the ice down to the depths, feeding life far below the surface. The sea can be mapped by its sounds. Just as land animals use distinct calls to communicate, marine creatures leave their acoustic fingerprint in the ocean. Scientists use these distinct sounds to map the locations and movements of whales, dolphins, and fish. They can even use sound to identify different populations based on their unique accents or dialects. Sound is the lifeline of the ocean, a way to see in the invisible darkness and to find companions over vast distances. The mesopelagic zone is the twilight zone. As you descend past 200 meters, the sun begins its final fading. This is the mesopelagic zone, also known as the twilight zone. Here, light is very dim and blue, but sunlight cannot reach the bottom of this zone. The depths go from about 200 to 1,000 meters. It is a place of strange adaptations. Creatures that live here must be able to hide in the weak light or find ways to hunt in it. The twilight zone is home to some of the most abundant animals on Earth, including strange creatures that carry their own lanterns. Many fish here travel up to the surface at night to feed and then return deeper in the day in a great vertical migration. This is the largest migration of animals on the planet, happening every day and night right under our noses. There is an invisible layer called the deep scattering layer. For years, during World War II, naval sonar operators were baffled by a false bottom that seemed to move up and down with the time of day. They thought it was the seafloor rising up at night. But it was actually a massive migration of fish, squid, and jellyfish living in the twilight zone. These creatures have gas-filled swim bladders or small bodies that reflect sound. When they cluster together by the millions at night, they rise to feed, and by day, they sink into the safety of the darkness. This moving layer has become known as the deep scattering layer, and it contains enough biomass to dramatically impact the global carbon cycle, removing tons of carbon from the ocean daily. Creatures in the twilight zone are often red or transparent. To protect themselves from predators with keen eyesight, many fish in the twilight zone have evolved to be red. Remember, red light is the first to be absorbed by the water, so at the depth of the twilight zone, a red fish looks black, perfect for camouflage against the dark background. Others are completely transparent, like glass, allowing them to pass through the blue unnoticed. It is a world of ghosts and shadows, where seeing is an easy thing to lose, and being seen is the danger. Some fish in the twilight zone have eyes like giant telescopes. To make sense of the faint blue penetrating light that eventually reaches them deep here, certain fish, such as tube eyes, have developed enormous, green-lensed eyes that are highly sensitive and point upward like a tunnel. These can house lenses larger than an orange. These eyes are perfectly sensitive to the tiny, faint silhouettes of creatures that might pass above in the weak light. It allows them to scan the vast nothingness above for any shadow that might signal a meal. Their bodies are mostly water-filled tubes, allowing them to float with little effort, waiting for prey to float above. The twilight zone is called the day-night migration zone. Every night, the largest animal migration on Earth occurs. Trillions of organisms, from tiny krill to jellyfish and small fish, rise from the twilight zone to the surface to feed under the cover of darkness. Then they return to the deep before the sun rises. It is a diurnal migration, a rhythm that moves carbon from the surface down to the depths, feeding deep-sea creatures and locking away carbon that would otherwise remain in the atmosphere. It is an event that is crucial for the health of the ocean, and yet happening in complete silence. The ocean is heavier than you can imagine. As you descend, the weight of the water above you increases enormously. For every 10 meters you go down, the pressure increases by 1 atmosphere. By the time you reach the bottom of the Mariana Trench, the pressure is more than 1,000 times that of the surface. It is equivalent to an elephant standing on your thumb. Yet here creatures live. They have adapted by losing air spaces inside their bodies. Their lungs and swim bladders are different or absent, and their bodies are filled with water and oils instead of air, which cannot be crushed. Life here is not broken, it is simply different, sculpted by force. There are underwater waterfalls taller than any on land. Beneath the waves, between the coast of Greenland and Iceland, lies a cold, dense current that flows over the ledge of an underwater ridge. This is called the Denmark Strait Cataract. It is an underwater waterfall where water drops nearly 3,505 meters, making it taller than Angel Falls in Venezuela, the tallest waterfall on land. But because it is water falling through water, you cannot see it. You can only measure its flow. It carries 5 million cubic meters of water per second, a powerful, hidden force eroding the seafloor, shaping the topography of the deep in complete silence. It is a reminder that gravity rules the ocean just as it rules the land. The ocean has depth zones defined by life. Biology divides the ocean into zones based on how far down light penetrates, and where life manages to survive. The epipelagic, or sunlight zone, is where we all live. Then the mesopelagic, or twilight zone, where light fades. Below that is the bathopelagic zone, called the midnight zone. Here is complete and utter darkness. No light reaches here at all. Below that is the abyssopelagic, the abyss, and finally the hadopelagic, the trenches, which are the deepest parts of the seafloor. Each zone is a world unto itself, with creatures found nowhere else on Earth, isolated by the cruelty of depth and pressure. There are seamounts that act as underwater islands. Scattered across the ocean, Great seamounts rise from the floor but never breathe the surface. They are like underwater mountains, and they are biodiversity hotspots. As ocean currents flow over them, they push nutrient-rich water up, bringing food from the deep to the summits. This creates tiny ecosystems in the middle of nowhere. These seamounts often serve as stepping stones for deep-sea creatures, allowing them to spread from one place to another. They are isolated oases of life in the deep blue desert. There are lakes and rivers on the ocean floor. One of the strangest discoveries in the deep sea is the existence of underwater lakes and rivers. These are brine pools, densely salty basins on the seafloor where the salinity is so high that the water becomes heavy and does not mix with the surrounding seawater. It sits in a pool, like a lake at the bottom of the ocean. Sometimes these brine pools overflow, creating rivers of heavy salt water that flow along the seafloor canyons. The edges of these pools are often lined with mussels and clams that have adapted to the extreme toxicity of the brine. It is a world within a world, a quiet shoreline in the crushing dark. The deepest part of the ocean is called the Challenger Deep. Located in the southern end of the Mariana Trench, the Challenger Deep is the deepest known point in the Earth's oceans. It is nearly 11,000 meters deep. If you were to place Mount Everest at the bottom, its peak would still be over a mile underwater. The pressure here is immense, the water is just above freezing, and it is eternally dark. Yet, even here, in the remotest part of the planet, we have found life. Simple, single-celled organisms called foraminifera thrive in the mud, proving that life can exist in even the most hostile corners of existence. The deepest fish ever found was the Mariana snailfish. For a long time, scientists believed that fish could not survive below 8,000 meters. The pressure was simply thought to be too great for their bones and muscles to function. But in 2017, researchers discovered the Mariana snailfish swimming happily at 8,178 meters. It is a small, translucent, scaleless fish with a tail like an eel and large teeth. It does not look like a monster, it looks fragile. But it is perfectly adapted, with flexible bones and a body that is supported by the water pressure rather than crushed by it. It is the undisputed king of the deep. Bioluminescence is the light of the deep. In the eternal darkness of the midnight zone and below, making your own light is a powerful tool. It is called bioluminescence, and it is produced by a chemical reaction inside the creature's body. It is used for hunting, for mating, and for defense. Some deep-sea creatures have a lure that dangles in front of their mouths, glowing in the dark to attract curious prey. Others release a cloud of glowing liquid, like a smoke bomb, to confuse predators while they escape. It is a silent language of light, flashing and fading in the pitch black. The anglerfish uses a light to lure its prey. One of the most famous deep-sea dwellers is the anglerfish. In the darkness of the bathypelagic zone, food is scarce. The female anglerfish has evolved a clever adaptation. She has a long dorsal spine that protrudes from her head, with a glowing tip filled with bioluminescent bacteria. She floats motionless in the water, waving this glowing lure in front of her mouth. Smaller fish, seeing the only light in the abyss, swim closer to investigate, only to be snapped up by her jaws. It is a patient, deadly waiting game played in the dark. The male anglerfish is a tiny parasite. While the female anglerfish can grow to the size of a human head, the male is tiny, often no larger than a small finger. For a long time, scientists couldn't figure out where the male anglerfish were. They eventually discovered that the males spend their entire lives searching for a female in the vast emptiness. When he finds her, he bites into her side, and his body fuses with hers. His blood supply joins hers, and he slowly loses his eyes and his internal organs, becoming nothing more than a permanent sperm provider. It is a bizarre, romantic, and gruesome dependency, ensuring that in the vast empty dark, they will never be apart from one another. The vampire squid is not a vampire or a squid. Its Latin name translates to vampire squid from hell. But this creature is actually quite gentle. It is the only known survivor of an ancient order of cephalopods. It lives in the oxygen minimum zone, a layer of the ocean where oxygen levels are dangerously low. Other creatures cannot breathe here, but the vampire squid has adapted by having an incredibly slow metabolism and a special type of hemoglobin that can bind oxygen even when it is very scarce. Instead of hunting live prey, it drifts through the dark, eating marine snow, bits of organic debris that drift down from the surface, and it has a cloak of webbing that it can pull over its entire body like a cape. There is a creature with a transparent head. The barrel-eye fish, found at depths of around 600 to 800 meters, has one of the most bizarre adaptations in the animal kingdom. Its head is completely transparent, filled with a fluid that allows you to see its internal organs. But most importantly, you can see its eyes. Its eyes are large, green, barrel-shaped tubes that sit inside its head, looking directly up. The transparent shield acts like the canopy of a fighter jet, protecting the eyes as it scans the water above for the silhouettes of prey. It sees through itself, looking out into the darkness from a glass house of its own making. The ocean floor is covered in marine snow. Everything that lives in the ocean eventually dies. And when it dies, it begins to sink. The bits of dead plankton, fecal pellets, and other organic materials slowly drift down through the water column, settling on the seafloor. This constant gentle shower of debris is called marine snow. It is the primary food source for deep-sea creatures like sea cucumbers and brittle stars. Without this slow drift of material from the sunlit world above, the bottom of the ocean would be a barren wasteland. It is the life-giving dust of the deep. There are worms that eat bones. When a large whale dies and its massive carcass sinks to the bottom, it provides a feast for deep-sea creatures for decades. Among the scavengers that come to feed are strange worms called oostax, or bone-eating worms. They have no mouths or stomachs. Instead, they send root-like structures into the bone of the whale to dissolve the fats and oils with the help of symbiotic bacteria. They turn the massive skeleton into a thriving garden of feathery red tubes, extracting the last bit of nutrition from the giant bones, recycling the whale back into the ecosystem. Giant tube worms live in boiling water. Near hydrothermal vents on the seafloor, cracks in the Earth's crust release superheated water rich in minerals. This water can be over 400 degrees Celsius. Most life would be boiled instantly, but here, giant tube worms thrive. They grow up to 2 meters tall and have no mouth, no stomach, and no eyes. They rely entirely on symbiotic bacteria living inside their bodies to convert the toxic hydrogen sulfide from the vents into energy. It is a world that runs on chemical energy rather than sunlight, a dark, alien ecosystem that hints at what life might look like on other moons or planets. There are corals in the deep sea that live for thousands of years. When we think of coral, we usually think of tropical reefs in shallow, warm water. But the deep ocean is also home to vast coral gardens. These cold water corals grow very slowly in the dark depths, feeding on particles drifting by. Because they grow so slowly and live in such stable, cold environments, they can live for incredibly long times. Some deep-sea black corals have been found to be over 4,000 years old, making them some of the oldest living animals on the planet. They have witnessed the rise and fall of civilizations while silently swaying in the deep currents. There is a ghostly jellyfish that lives in the deep. The Stygiomedusa gigantea is a giant deep-sea jellyfish that can grow to be over 1 meter across. It is rarely seen because it lives at depths of over 1,000 meters. It has a massive, bell-shaped hood and 4 ribbon-like arms that trail behind it, rather than the stinging tentacles of shallow-water jellies. It drifts through the midnight zone like a ghostly sheet, pulsing slowly, undisturbed by the chaos of the world above. It is a reminder that beauty exists even in the harshest deserts of the sea. The ocean has a twinkling effect at night. Sometimes, when sailors or divers are in the dark waters at night, the water around them seems to sparkle and glow with every movement. This is caused by dinoflagellates, a type of plankton, when they are disturbed. They release a flash of light as a defense mechanism, meant to startle predators. It creates a magical, ethereal glow in the wake of a boat or around a swimming hand. It is the ocean responding to touch, lighting up the darkness in a moment of fleeting brilliance before fading back into the dark. The ocean hides the loudest sound ever made. In 1991, the National Oceanic and Atmospheric Administration detected an ultra-low frequency sound coming from the deep Pacific Ocean. It was so loud that it was heard by sensors thousands of miles away. They called it the bloop. It sounded like a massive biological cry. For years, people speculated it was a giant sea monster. However, scientists eventually determined it was the sound of an ice wake, a massive cracking and collapsing of ice in the Antarctic. It was a geological event, not a beast, but for a moment, it reminded us how much we still don't know about the noises in the deep. The pressure affects the chemistry of life. At the bottom of the ocean, the intense pressure affects the way proteins fold in a creature's body. Proteins are the building blocks of life, and they need to hold a specific shape to work. Under high pressure, proteins tend to unfold and stop working. Deep-sea creatures have evolved to have special proteins with more rigid structures, often containing a molecule called T-mail, which acts as a stabilizer, protecting their biological machinery from being crushed. It is a microscopic defense against a macroscopic force. The ocean floor creates new crust. Midway between the continents, there is a massive mountain range that circles the entire globe like the seam on a baseball. It is the mid-ocean ridge. Here, molten rock rises from the mantle to create new crust, pushing the ocean floor apart. It is the very factory of the Earth's surface. Hydrothermal vents found here spew black smoke and support unique life forms. This ridge system is the largest volcanic feature on Earth, a place where the planet is constantly renewing itself, spreading out from the cracks in the dark. The Sofar Channel is a hidden highway. In the ocean, there is a specific depth where the speed of sound is at its minimum. This depth, which varies depending on temperature and salinity, is called the Sofar Channel, or sound fixing and ranging channel. Sound waves that enter this channel get trapped and can travel for thousands of kilometers without losing energy. Whales often use this channel to sing to one another across oceans. It is like a fiber optic cable of sound, a hidden layer in the sea where whispers can be heard half a world away. The ocean is a carbon sink. The ocean plays a crucial role in regulating the Earth's climate. It absorbs vast amounts of carbon dioxide from the atmosphere, acting as a buffer against global warming. The cold waters near the poles absorb CO2, which then sinks, locking it away in the deep ocean for centuries. However, this comes at a cost, as the acidification alters the water chemistry. It is a delicate balance, a service the ocean provides for us, silently taking in what we produce, protecting the land from the harshest effects of our emissions. There are forests of kelp that rival land forests. While not deep in the abyss, kelp forests are dense underwater ecosystems found in cold, nutrient-rich waters. They are the fastest-growing plants on Earth, some species growing up to 60 centimeters a day. These towering underwater forests provide food and shelter for thousands of species, from sea urchins to sea otters. They act as carbon sinks too, capturing carbon as they grow. They are the lungs of the coastal ocean, swaying gently with the tides, anchoring life to the rocky bottom. Deep-sea gigantism is a real phenomenon. There is a strange tendency for deep-sea creatures to grow much larger than their shallow-water relatives. The giant squid, the giant isopod, and the Japanese spider crab are all examples of this. Scientists aren't entirely sure why this happens. One theory is Bergmann's rule, which suggests that larger animals hold heat better though the deep is cold. Another theory is that being larger helps them travel further distances in the food-scarce abyss. It is a world where the small become the massive, growing to sizes that seem monstrous to us, yet are perfectly normal there. The ocean has a layer where oxygen is minimal. Between the oxygen-rich surface waters and the oxygen-rich deep waters, there is often a layer known as the oxygen minimum zone, OMZ. Here, the amount of dissolved oxygen is so low that most marine life cannot survive. Yet, this zone is teeming with microbes that have adapted to live without oxygen. These organisms play a vital role in the nitrogen cycle, converting nutrients into forms that other life can use. It is a band of water that is suffocating to most, but a sanctuary to the microscopic few. The sea floor stores the history of the world. On the bottom of the ocean, sediment has been piling up for millions of years. Deep beneath the layers of mud and clay lies a record of Earth's history. These sediments contain the shells of ancient microorganisms, volcanic ash, and dust from meteors. By drilling into the seafloor, scientists can read this history like a book, learning about past climates, mass extinctions, and the movement of continents. The ocean floor is the ultimate archive, keeping the memories of the planet safe in the dark. Some deep-sea creatures have eyes that are always open. In the midnight zone, where the sun does not reach, eyes are less useful, but some creatures have evolved to see the faint light created by other animals. The telescope fish has eyes that point permanently upward to spot shadows. The spookfish has mirrors behind its retinas to focus light, rather than lenses, making it the only vertebrate known to use a mirror to see. They are constantly watching the dark, waiting for a glimmer of light to betray the presence of a neighbor or a meal. The ocean regulates our temperature. The ocean acts like a giant heat sink. It absorbs heat from the sun during the summer and releases it during the winter, moderating the Earth's climate. It keeps the poles from getting too cold and the equator from getting too hot. Without the ocean's ability to store and transport heat, the Earth would be a place of wild temperature swings, inhospitable to most life. It is the great thermostat of our world, silently balancing the scales. There is a species of shrimp that creates a shockwave. The pistol shrimp is a small creature with a very large claw. It snaps this claw shut so quickly that it shoots a jet of water at 100 kilometers per hour. This creates a low-pressure bubble that collapses with a sound louder than a jet engine and produces a flash of light. The shockwave is powerful enough to stun small fish, which the shrimp then eats. It is one of the loudest sounds produced by any marine animal, coming from a shrimp that fits in the palm of your hand. The ocean contains vast deposits of minerals. On the seafloor, there are rocks called manganese nodules. They are potato-sized lumps scattered over vast plains of the deep abyss. They contain valuable metals like manganese, iron, cobalt, and nickel. They have formed over millions of years by the slow precipitation of metals from seawater. For decades, countries have been looking at mining them, but doing so would disturb the fragile, slow-growing ecosystems of the deep. They are the gold nuggets of the abyss, waiting in the dark. The ocean is full of plastic. We cannot talk about the deep ocean without mentioning the human footprint. Microplastics have been found in the deepest trenches of the ocean. They drift down from the surface, settling in the mud. Even the deepest amphipods have been found with plastic fibers in their stomachs. It is a tragedy on a planetary scale. The things we throw away travel to the most remote places on Earth, contaminating the ancient, pristine mud with our refuse. It is a reminder that the ocean is not separate from us. It is connected to us in every way. The ocean floor moves like a conveyor belt. At the mid-ocean ridges, new crust is created. As it moves away from the ridge, it cools, becomes denser, and eventually, millions of years later, sinks back into the mantle at subduction zones, like deep ocean trenches. This cycle takes about 200 million years. The entire ocean floor is recycled. The rocks at the bottom of the ocean are actually much younger than the continents. It is a slow, relentless recycling of the planet's skin, creating and destroying the bed of the sea. There are creatures that have no blood. Ice fish, found in the cold waters around Antarctica, have a unique adaptation. They have no hemoglobin, the protein that carries oxygen in the blood. This makes their blood clear and colorless. They can survive because the freezing waters of the Antarctic are rich in dissolved oxygen, and the fish have large hearts and pump their blood rapidly. They are the only known vertebrates to lack red blood cells, a strange and ghostly evolution to survive the cold. The ocean floor has mountains taller than Everest. Mauna Kea in Hawaii is often cited as the tallest mountain on Earth, if measured from its base on the ocean floor. It rises over 10,000 meters from the seafloor to its peak, surpassing Mount Everest. The ocean hides these giants beneath its waves, entire mountain ranges that we never see until we map the bottom from a ship. It is a world of vertical landscapes, canyons deeper than the Grand Canyon, and plains wider than any continent, all hidden under the blue. There is a jellyfish that can live forever. The Turritopsis dohrnii, often called the immortal jellyfish, is about the size of a pinky fingernail. When it faces starvation or physical damage, instead of dying, it reverts its cells back to their earliest form, a polyp. It essentially turns back into a baby and starts its life over again. It can do this repeatedly, theoretically bypassing death. While they are often eaten by predators, biologically, they have found a way to cheat time, floating endlessly in the currents, returning to the beginning whenever the end approaches. The ocean absorbs about 1/3 of human-caused carbon dioxide. Since the Industrial Revolution, the ocean has absorbed roughly 1/3 of the carbon dioxide humans have emitted. This has helped slow the pace of global warming, but it has changed the chemistry of the seawater, making it more acidic. This ocean acidification reduces the ability of shellfish and coral to calcify, threatening the foundations of the marine food web. It is a silent service the ocean performs for us, absorbing our excess, but one that is taking a toll on the life within it. There is a creature called the sea pig. Scallops are not the only pigs in the ocean. The sea cucumber species known as the scotoplane, or sea pig, is a strange creature that lives on the deep seafloor. It looks like a pink, inflated balloon with several pairs of large, tube-like legs. It walks along the mud, scavenging for detritus. It is a crucial part of the ecosystem, turning over the seafloor sediment as it moves. They are often found in herds, walking slowly across the abyssal plain, the vacuum cleaners of the deep. The ocean creates weather. The sun heats the ocean unevenly. The water near the equator is warmer than the water near the poles. This difference in heat drives the atmosphere, creating winds and storms. Hurricanes and typhoons derive their energy from the warm waters of the tropics. The ocean and the atmosphere are a coupled system, dancing together. The weather you experience on land often starts in the water, a transfer of heat and moisture that dictates the rhythm of the skies. There are corals that glow in the dark. Some deep-sea corals produce their own light, a phenomenon known as bioluminescence. They absorb blue light, the only light that reaches them, and emit it in other colors like neon green and red. Scientists believe this might protect them from UV light, help them communicate, or attract food. It turns the dark, cold reefs into a hidden neon city, glowing with colors that our eyes cannot see without special equipment. The ocean floor is covered in veins. As magma cools beneath the ocean crust, it contracts and cracks. These cracks fill with seawater. This water superheats and leaches minerals from the rock, creating a fluid rich in metals. When it spews out of hydrothermal vents, the minerals precipitate out, forming towering chimneys. Over time, these veins become massive deposits of ore. The seafloor is literally riddled with the plumbing of the planet, carrying the heat and minerals of the Earth's mantle. The ocean is home to the largest animal migration. Every day, animals move up and down in the water column in what is called the diel vertical migration. This migration involves billions of tons of biomass, moving vertically hundreds of meters every 24 hours. It is primarily a way to avoid predators, feeding in the dark at the surface and hiding in the dark at the depths. It is the largest movement of biomass on the planet, a daily commute that happens in the dark, unseen by the world above. There is a fish that lives on land. The mangrove killifish can survive out of water for up to 66 days. It lives in temporary pools and mangrove swamps that can dry up. When the water evaporates, this fish tunnels into hollow logs or the mud. Its gills are altered to hold onto water and nutrients, and it breathes through its skin. It waits for the rain to return, essentially living on land like an amphibian. It is an adaptation to the unpredictable rhythm of the coastal tides. The ocean has a layer called the thermocline. As you go deeper, the temperature of the water drops rapidly in a specific band known as the thermocline. This acts as a barrier to mixing between the warm surface water and the cold deep water. Sound and light behave differently across this boundary. Many sea creatures, like whales and submarines, use this layer to hide or communicate, as it can reflect sound waves. It is an invisible wall in the water that separates the warm sunlit world from the cold deep. The ocean stores gold. Every drop of seawater contains trace amounts of gold. It is estimated that the ocean contains about 20 million tons of gold dissolved in it. However, the concentration is so incredibly low, parts per trillion, that extracting it would cost more than the gold is worth. It is a diluted fortune, glittering invisibly in the water, a treasure that no one can practically claim. The ocean floor is home to brinnacles. Under the ice of the polar oceans, a strange phenomenon occurs. When sea ice forms, it expels salt, creating super cold, super salty brine. This brine is denser than the surrounding water and sinks. As it sinks, it freezes the fresher water around it, forming a tube of ice that descends to the seafloor like an icicle hanging from a ceiling. These brinnacles, or ice stalactites, can freeze starfish and crabs on the bottom, creating a lethal finger of ice in the cold dark. The ocean has a zone where sound is focused. Due to the physics of pressure and temperature, there is a specific depth in the ocean where sound is trapped and travels extremely efficiently. This is the Sofar Channel. Whales sing in this channel, and submarines hide in it. A sound made off the coast of Australia can be heard off the coast of Bermuda through this deep acoustic tunnel. It is a hidden layer of the sea where the vibrations of life travel further than anywhere else. The ocean floor is constantly eroding. Just as the land is eroded by wind and rain, the ocean floor is eroded by the water itself. Underwater currents, especially those that follow the contours of the bottom, can scour the seabed, carving out furrows and smoothing rocks. These turbidity currents, underwater avalanches of sediment, can reshape the landscape in minutes. It is a slow, grinding wear, smoothing the skin of the planet under the weight of the water. There is a fish that walks on the seafloor. The frogfish is a master of camouflage. It looks like a sponge or a piece of coral. It doesn't swim well. Instead, it uses its modified fins to walk along the reef or the seafloor. It waits motionless for prey to come close, then strikes with lightning speed. Some species even have a lure that looks like a worm to attract their victims. It is a hunter that merges with the furniture of the sea, walking slowly across the bottom. The ocean has a memory. Through the study of deep-sea sediment cores, scientists have reconstructed the climate history of the Earth going back millions of years. The shells of microscopic foraminifera preserve the chemical signature of the temperature at the time they died. By analyzing these ancient shells buried deep in the mud, we can see how the ice ages came and went, and how the ocean responded. The seafloor is a library, holding the records of a changing world in layers of dust and shell. The ocean floor is covered in tracks. Despite the vast emptiness of the deep, the seafloor is not smooth. It is covered in trails and tracks left by deep-sea creatures. Worms burrowing through the mud, sea cucumbers trawling for food, and crabs scuttling across the clay all leave their marks. Because the sediment settles so slowly, these tracks can last for a very long time, creating a patchwork of lines and dots on the abyssal plain, the footprints of a hidden world. The ocean is a thermal mass. It takes a long time to heat up and a long time to cool down. This thermal inertia is why the seasons are delayed by about a month or two. The ocean holds on to the heat of summer well into autumn. It stabilizes our climate, ensuring that the temperature of the Earth doesn't swing wildly from day to night or season to season. It is the giant battery that stores the sun's energy and releases it slowly over time. There are forests of glass sponges. In the deep waters of Antarctica, there are vast forests of glass sponges. They are made of silica, the same material as glass, and they form intricate, lattice-like structures. Some are so large they are considered thousands of years old. They provide a habitat for other deep-sea animals, creating a city of glass on the seafloor. They filter vast amounts of water, cleaning the deep oceans in their slow, silent way. The ocean floor has canyons deeper than the Grand Canyon. The Monterey Canyon off the coast of California is a massive underwater canyon that is deeper and longer than the Grand Canyon. It was likely carved by an ancient river when sea levels were lower, and is now deep underwater. These canyons channel sediment from the continent out to the deep sea and are rich hotspots for biodiversity, acting as highways for nutrients and marine life. There is a creature called the vampire squid. Despite its name, the vampire squid does not suck blood. It feeds on marine snow, drifting debris of dead plants and animals. It has a cloak of webbing between its arms that it can pull over its body like a cape when threatened, revealing spiny projections called cirri. It lives in the oxygen minimum zone, where few other creatures can survive, drifting gently through the dark on small flaps that it uses like fins. The ocean creates its own currents. The wind drives the currents at the surface, but the deep ocean is driven by density. Cold, salty water is denser than warm, fresh water. It sinks, pushing the deep water around the world. This thermohaline circulation is driven by differences in temperature and salinity, and it is the main mechanism that distributes heat around the globe. It is the global engine, powered by the coldness of the poles. The ocean floor is made of basalt. Unlike the continents, which are made mostly of granite, the ocean floor is made of basalt. Basalt is a dark, dense volcanic rock. It is constantly being created at the mid-ocean ridges and destroyed in the trenches. This difference in rock density is why the continents sit higher than the ocean floor, and why water flows into the low basins. It is the geology of the deep, the dark rock that forms the bed of the sea. There is a fish that lives in shells. The hermit crab is famous for burrowing shells, but there are deep-sea crustaceans that also utilize the empty homes of others. In the deep, shells can be scarce resources. Some hermit crabs have been known to use discarded human debris like glass bottles or pipes when natural shells aren't available. It is a sad reflection of human impact, but also a testament to the adaptability of life, turning our trash into a mobile home. The ocean is a source of medicine. Many of the drugs used today come from the ocean. Sponges and corals produce complex chemicals to defend themselves from infection and predators. Scientists are studying these compounds to create new antibiotics and treatments for cancer and Alzheimer's. The deep sea, with its strange chemical environments like hydrothermal vents, is a vast untapped pharmacy, holding cures for diseases we have yet to discover, hidden in the bodies of the strangest creatures. There is a creature called the basket star. Related to starfish, the basket star is a deep-sea dweller with long, branching arms that split repeatedly, looking like a complex, tangled net. It unfurls these arms into the current to catch drifting food particles. When it is disturbed, it curls its arms up into a tight ball. It is a delicate, intricate creature that looks like a sculpture, filtering the water in the darkness with its sprawling net. The ocean floor has hydrothermal vents that are black smokers. These are chimneys on the seafloor that spew superheated, mineral-rich water. The water is black because it is full of dissolved metals, which precipitate when they hit the cold seawater, creating black smoke. These vents can reach temperatures of 400 degrees Celsius. Despite the heat, they support thriving ecosystems of tube worms and giant clams, living in a world of boiling water and total darkness. The ocean creates clouds. The ocean is the source of most of the moisture in the atmosphere. As water evaporates from the surface, it rises and condenses to form clouds. Tiny particles called aerosols, produced by phytoplankton, act as seeds for cloud droplets. These clouds reflect sunlight and cool the planet. So, the tiny plants in the water are actually helping to control the climate in the sky, connecting the deep blue to the white clouds above. There are creatures that live their entire lives in the nustan. The nustan is the very surface of the ocean. Creatures like the Portuguese man-o'-war float here, their sails catching the wind. There is also a tiny snail called the violet snail that builds a raft of bubbles to float on the surface, hunting jellyfish. It is a thin, unstable layer where air and water meet, a habitat built entirely on the interface of two worlds. The ocean floor has abyssal plains. These are vast, flat areas of the deep ocean floor. They are among the flattest, smoothest places on Earth, covered in a thick layer of sediment that has settled over millions of years. They are the deserts of the deep, quiet and stable, dotted only occasionally by manganese nodules or the tracks of wandering sea cucumbers. There is a fish called the tripod fish. Living on the abyssal plain, the tripod fish has long, stiff rays extending from the lower part of its tail fin. It stands on these like a tripod, hovering just above the muddy seafloor. This keeps it just high enough to feel the vibrations of prey swimming by in the currents. It doesn't need to see, it feels its food in the dark, standing still on the mud. The ocean creates tides. The gravitational pull of the moon and the sun creates the rise and fall of the tides. This rhythmic movement is like the breathing of the ocean, stirring the coastal waters, bringing nutrients up from the bottom, and flushing the estuaries. It is a clock that has been ticking for billions of years, driving the rhythm of life for crabs, turtles, and shorebirds. The ocean floor is where the continents meet. The continental shelves are the shallow edges of the continents that extend out into the ocean before dropping off steeply into the deep. These shelves are the richest fishing grounds in the world, because sunlight reaches the bottom here, allowing plants to grow and supporting the food chain. They are the rim of the bowl that holds the ocean. There is a creature called the sea spider. Sea spiders are not true spiders, but they look like them, with very long legs and a tiny body. They live in the deep ocean, and some can grow to be quite large, with leg spans of up to 70 centimeters. They don't have lungs. They absorb oxygen through their legs. They are strange, delicate walkers, roaming the deep floor in search of sponges and anemones. The ocean has a layer called the halocline. In some places, especially near melting ice or underwater rivers, there is a sharp change in salinity called the halocline. Because salt water is denser than fresh water, it can create a visible layer in the water where the two types of water meet. If you were to dive through it, you would see the distortion in the water as light travels through the different densities, a blurry window separating two worlds of water. The ocean floor is home to glass sponges that can live for 15,000 years. In the Antarctic deep sea, there are glass sponges that grow extremely slowly. Some of the largest individuals have been estimated to be over 15,000 years old. They have witnessed the entire history of human civilization from the dark, cold depths of the Antarctic shelf. They are the oldest living animals on the planet. There is a creature called the dragonfish. The deep-sea dragonfish is a predator with a long, slender body. It has a barbel attached to its chin that glows with a bioluminescent lure to attract prey. It also has a row of photophores along its side that flash a red light. Most deep-sea creatures can only see blue light, so the dragonfish uses this red light as a sniper scope to illuminate its prey without them knowing they are being watched. The ocean floor has mountains and volcanoes. The seafloor is not flat. It is dotted with seamounts, geos, flat-top seamounts, and active volcanoes. There are more volcanoes under the ocean than on land. They are constantly erupting and creating new land, though most of it remains deep underwater. It is a geologically active place, where the Earth's crust is constantly being remade. The ocean is the Earth's thermostat. The ocean absorbs heat from the equator and moves it toward the poles. This movement, through currents like the Gulf Stream, ensures that the distribution of heat is relatively even. Without this transport, the tropics would be unbearably hot, and the poles would be locked in deep ice. The ocean moderates our world, keeping it in a habitable range. There is a fish called the hatchetfish. The hatchetfish has a body shaped like the blade of a hatchet, very thin and compressed. This shape allows it to hide its silhouette when viewed from below. Its sides are so thin that it is almost invisible. It lives in the mesopelagic zone and uses large, tubular eyes to spot prey above. It is a master of camouflage, hiding in the plane of the light. The ocean floor is covered in sediment. The deep ocean floor is covered in a layer of sediment called pelagic ooze. This is made up of the microscopic remains of dead organisms that have rained down from the surface for millions of years. It is soft and muddy, composed of the skeletons of diatoms and foraminifera. It is a deep, slow accumulation of life, turning into rock over time. The ocean creates dead zones. In areas where too many nutrients enter the ocean, usually from agricultural runoff, algae blooms occur. When these algae die and decompose, they consume the oxygen in the water, creating a dead zone, where oxygen levels are too low for life to survive. These are spreading in the ocean, a sign of the imbalance we are causing in the chemical systems of the sea. There is a creature called the stargazer. The stargazer is a fish that buries itself in the sand on the seafloor, leaving only its eyes and mouth visible. It looks up, waiting for prey to swim overhead. It has a large mouth and can even produce an electric shock to stun its victims. It is an ambush predator, disguised as the sand itself, waiting patiently for food to pass by. The ocean floor is broken into plates. The Earth's crust is not one solid piece. It is broken into tectonic plates. The ocean floor is made of these plates, which move apart at the ridges and collide at the trenches. This movement creates earthquakes and volcanoes. It is the restless, shifting foundation of the deep, driving the slow geological dance of the continents. The ocean has a twilight sound. In the mesopelagic zone, there is a phenomenon known as the twilight chorus. As the sun sets, deep-sea creatures migrate up, and their sounds increase. The ocean becomes a noisy place at dusk and dawn, a symphony of clicks and whistles as the animals commute to the surface. It is the rush hour of the deep, played out in the dark. There is a fish called the blobfish. The blobfish lives at depths of about 600 to 1,200 meters. At this depth, the pressure is very high. The blobfish has a gelatinous body with very little muscle and no bones, which allows it to float without expending energy. When brought to the surface, it expands and looks like a sad, melting blob. But in its home deep down, it looks like a normal fish, adapted perfectly to the crushing pressure. The ocean is a source of mystery. Even with all our technology, the ocean remains largely unknown. We have mapped the surface of Mars more accurately than we have mapped the seafloor of our own planet. Every time we dive down, we discover new species and new ecosystems. It is a final frontier right here on Earth, holding the secrets of our past and the keys to our future, hidden in the blue. There is a creature called the giant tube worm. Living at hydrothermal vents, these worms can grow to over 2 meters in length. They have no mouth, no stomach, and no eyes. They rely entirely on symbiotic bacteria living inside their bodies to turn the toxic chemicals from the vents into food. They are bright red, filled with blood that carries oxygen and hydrogen sulfide to the bacteria. They are alien giants, farming chemicals in the dark. The ocean floor has abyssal hills. Covering vast areas of the seafloor are small hills, usually less than 100 meters high. They are the most common landform on Earth, covering millions of square kilometers. They are thought to be formed by the interplay of volcanic activity and faulting at the mid-ocean ridges. It is a rolling, bumpy landscape that stretches on endlessly under the water. The ocean creates icebergs. When glaciers break off from the continents and fall into the sea, they create icebergs. These floating islands of fresh water drift with the currents and eventually melt. As they melt, they release fresh water and trap sediment into the ocean, affecting the salinity and nutrient levels. They are the drifting castles of the poles, slowly dissolving into the sea. There is a creature called the Yeti crab. Discovered near hydrothermal vents in the Southern Ocean, the Yeti crab has hairy claws covered in bacteria. It farms these bacteria on its claws, waving them in the chemical-rich water to feed the bacteria. Then, it scrapes the bacteria off to eat. It is the only known organism to farm its food on its own body. And now, the currents begin to slow as you drift deeper into rest. If this quiet exploration helped you unwind or gave you a peaceful moment, you are welcome to like and subscribe to the channel. It helps others find their way to this calm corner of the internet. One deep breath at a time. And if you happen to still be awake, there will be another story waiting on the screen whenever you are ready. A new horizon to drift toward whenever you need it. But for now, allow the bed to hold you. Unclench your jaw. Let your shoulders fall away from your ears. Breathe in and breathe out. A little slower with every cycle. The ocean will keep turning the tides, and the waves will keep rolling long after you close your eyes. The world is steady. You are safe. Sleep deep. Sleep well. And good night.